all. This is Dr. G. Kumar, Assistant Professor, Department of Physics, St. Joseph College for Women. Today we are discussing about the Unit 1 Vector Analysis. Content of vector analysis: scalar and vector fields, gradient of a scalar field and its physical significance, divergence, and curl of a vector field with derivations and physical interpretation, vector integrations like line integral, volume integral, and surface integral, stroke theorem and Gauss theorem. Physical quantities are two types. First one is the scalar and second one is the vector. Scalar means the physical quantity which is having only magnitude but no direction is called a scalar quantity. Examples: density, temperature, and etc. Next one, vector. The physical quantity which is having both magnitude as well as direction is called as a vector quantity. Examples are velocity, acceleration, force, and etc. Resolution of a vector. Vectors resolves into two components which are mutually perpendicular to each other. Let us consider a bar is a vector quantity. So this can be written in the two-dimensional format in the first figure. Ax bar is equal to mod a bar cos theta I cap. In y-axis, ay bar is equal to modulus of a bar sin theta j cap. So this can be resolved into two components like this. It is shown in the figure 2. So on x-axis, if we are taking cos alpha, f cos alpha is a one vector, so this can be in y-axis f sin alpha. Suppose if you are taking f sin theta on x-axis, so the mutual perpendicular shown in y-axis f cos theta. Representation of a vector. Let us consider a bar is a vector quantity. So a bar is equal to axi cap plus ayj cap plus az k cap, where I comma j comma k are the unit vectors of x comma y and z axis respectively. Here ax comma ay and az are the projections along x comma y and z axis respectively. Magnitude of a bar is equal to root over ax square plus ay square plus az square. Next one, unit vector. Unit vector is equal to a cap is equal to a bar by a. So we are substituting the values, so we will get the unit vector. A cap is equal to axi plus ayj plus azk by root over ax square plus ay square plus az square. Multiplication of a vectors. First one is the scalar product or dot product. If you are taking two vectors a and b, the product of the magnitudes of the two vectors and the cosine of the angle between them. So a dot b is equal to ab cos theta, where theta is the angle between the two vectors. So cos theta is equal to a dot b by ab. The product is a scalar quantity. The product may be positive or negative depending upon the angle theta. The product is negative when theta is in between pi by 2 and 3 pi by 2. So a dot b is equal to ab cos theta, that is equal to a b cos theta, that is equal to a cos theta b. Examples of the scalar product. First one is the work done. We know the formula W is equal to F dot S, where S is the displacement produced by the applied force. Second one is the potential difference. We know the formula V is equal to integral of E dot dl. Next one, vector product of the two vectors. So this can be simply known as a cross product of the two vectors. Here the magnitude is equal to the product of the two vectors and the sine of the angle between them. The direction is being perpendicular to the plane containing the vectors. Let's consider if A and B are the two vectors, then their vector product can be written like this: A cross B. A cross B is equal to AB sin theta into n cap. Here theta is the angle between them and n cap is the unit vector perpendicular to the plane of A and B. So this can be simply written like this: A cross B is equal to modulus of I j k ax ay az bx by bz. Examples of vector product: in a rotatory motion, the torque acting on a body tau is equal to r cross f. Next one is the angular momentum. So, and the linear momentum is denoted as L is equal to r cross p. Scalar field: if for each point P of r of a region R in space E, there corresponds a definite scalars denoted by f of r, then the f of r is called as scalar point function in space E. The space is called as a scalar field. For example, if you are taking any solid material that is focused with a different temperatures, now the temperature will vary from point to point. Here the temperature will be a function of position of coordinates. So that is called scalar field. Vector field: when a vector physical quantity is expressed from point to point in the space region by a continuous vector functions like a, x comma y comma z, then the region is called as a vector field. Examples: gravitational, magnetic and electrical intensity fields. Next one is the del operator. It is treated as a vector and is mathematically defined as del is equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Making use of del operator, we can convert a scalar field into a vector field or vector field into a scalar field. That is, E is equal to minus del dot V. E is equal to minus grad V. Gradient of a scalar field. The gradient of a scalar field S is a vector whose magnitude is equal to the rate of change of S at that point, whose direction is along the normal to the level surface at that point. It is denoted by del S or grad S. Grad S is equal to that is equal to del S is equal to I dou by dou x plus j dou by dou y plus k dou by dou s dot s. So this can be simply written like this: delta s is equal to I dou s by dou x plus j dou s by dou y plus k dou s by dou z. Standard one: show that grad of pi plus psi is equal to grad pi plus grad psi. We know that grad s is equal to del s. So by using that formula, I am rearranging all these things. So first of all, grad pi plus psi is equal to, so I dou by dou x of pi plus psi plus j dou by dou f of pi plus psi plus k dou by dou z of pi plus psi. We are separating here, pi terms are one side, psi terms are other side. So that is equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z plus I dou psi by dou x plus j dou pi by dou y plus k dou psi by dou z. This can be simply written like this: grad pi plus grad psi. Standard 2: if pi and psi are the scalar point functions, show that grad pi psi is equal to pi grad psi plus psi grad pi. We know the formula grad s is equal to del s. I am substituting the above formula here. Grad pi psi is equal to del pi psi, that is equal to I pi dou psi by dou x plus j pi dou psi by dou y plus k dou psi by dou z plus I psi dou pi by dou x plus j psi dou pi by dou y plus k psi dou pi by dou z. I am separating the pi terms and the psi terms. So that is equal to pi of, I am taking common as a pi. So pi of I dou psi by dou x plus j dou psi by dou y plus k dou psi by dou z plus, here I am taking pi as a common term, pi of I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So these two are similar like del s. So that is equal to pi grad pi plus psi grad pi. Standard 3. Show that grad r is equal to r cap. We know that r is equal to xi plus yj plus zk. We know the distance formula, r is equal to root over x square plus y square plus z square. So next one we have the formula grad r. Grad r means that is equal to del r. We know the del r formula, that is equal to I dou r by dou x plus j dou r by dou y plus k dou r by dou z. I am substituting the distance formula here. I dou by dou x of root over x square plus y square plus z square plus j dou by dou y of x square root over x square plus y square plus z square plus k of dou by dou z of root over x square plus y square plus z square. So after derivating of the with respect to x axis, y axis and z axis, we are getting the formula grad r is equal to I half x square plus y square plus z square whole to the power of minus 1 by 2 into 2x plus j of 1 by 2 into x square plus y square plus z square whole to the power of minus 1 by 2 into 2y plus k of 1 by 2 x square plus y square plus z square whole to the power of minus 1 by 2 into 2z. So simply that equation can be written like this: grad r is equal to xi plus yj plus zk by x square plus y square plus z square whole to the power of 1 by 2. So that is equal to r bar by r, that represents r cap. It represents a unit vector. Standard 4. Show that grad r power n is equal to n into r power n minus 2 into r cap. So we know the formulas, r is equal to xi plus yj plus zk. We know the distance formula, root over x square plus y square plus z square. So I am substituting the values in this equation. Grad r power n is equal to del r power n. So I am substituting the values of r here. The grad r power n is equal to I dou by dou x of x square plus y square plus z square whole to the power of n by 2 plus j dou by dou y of x square plus y square plus z square whole to the power of n by 2 plus k dou by dou z of x square plus y square plus z square whole to the power of n by 2. So after derivating with respect to x values, y values and z values, we are getting the values. Grad r power n is equal to I n by 2 of x square plus y square plus z square whole to the power of n minus 2 by 2 into 2x plus j n by 2 of x square plus y square plus z square n minus 2 by 2 into 2y plus k n by 2 of x square plus y square plus z square n minus 2 by 2 into 2z. After solving the equations, we are getting grad r power n is equal to n into x square plus y square plus z square whole to the power of n minus 2 by 2 into xi plus yj plus z square. So I am substituting the r values and r power n values here. So then we get grad r power n is equal to n into r power n minus 2 into r bar. Divergence of a vector field. If a vector field A bar at any point is the amount of flux at unit time per unit volume diverging from a point. The divergence is a scalar quantity. So expression div A bar is equal to del dot A bar, that is equal to I dou by dou x plus j dou by dou y plus k dou by dou z dot A is a vector, so axi plus ayj plus akj. So simply we can write like this: div A bar is equal to dou ax by dou z dou x plus dou ay by dou y plus dou az by dou z. This is the expression of divergence in Cartesian coordinates. Standard 5. Div of A bar plus B bar is equal to div A bar plus div B bar. So we know the formula: div A bar is equal to del A bar. So I am substituting the same formula here. So div A bar plus B bar is equal to del of A bar plus B bar. We know the del terms, that is equal to div A bar plus B bar is equal to dou by dou x of Ax plus Bx plus dou by dou y of Ay plus By plus dou by dou z of Az plus Bz. So I am separating the A values and B values here. So that is equal to dou by dou Ax by dou x plus dou Ay by dou y plus dou Az by dou z plus dou Bx by dou x plus dou By by dou y plus dou Bz by dou z. So simply, so it seems to be like a, so first term represents div A bar, second term represents div B bar. So at last div A bar plus B bar is equal to div A bar plus div B bar. Standard 8. Div of pi A bar is equal to pi div A bar plus grad pi dot A bar. So we know the formula: div A is equal to del A. So I am substituting the above values here. Div pi A bar is equal to dou by dou x of pi Ax plus dou by dou y of pi Ay plus dou by dou z of pi Az. Here A represents Axi plus Ayz plus Azk. So I am substituting the values. So after changing the values, so div pi A bar is equal to pi of dou Ax by dou x plus pi dou Ay by dou y plus pi dou Az by dou z plus Ax dou pi by dou x plus Ay dou pi by dou y plus Az dou pi by dou z. I am separating the pi values and the x values, A values. So that is equal to pi of, I am taking a common term as a pi of dou Ax by dou x plus dou Ay by dou y plus dou Az by dou z plus I am separating the, so Ax, Ay, Az values here. So Axi plus Ayj plus Azk into I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So Axi, Ay, Azk represents A bar. I am substituting the values here. So simply this can be written as pi of div A bar plus grad pi dot A bar. Next one is integration of a vector. That means the vector is in between the two fixed points. So the vector algebra, the integrations which are commonly used as one is a line integral, second one is the surface integral, and third one is the volume integral. Next one, curl of a vector field. The curl of a vector field is the maximum line integral per unit area. It is a vector quantity. So expression curl A bar is equal to del cross A bar. So this can be written like this: curl A bar is equal to modulus of Ijk dou by dou x dou by dou y dou by dou z Ax, Ay, Az. Standard 9. curl of a bar plus b bar is equal to curl a bar plus curl b bar. We know the formula curl s is equal to del cross s. I am using that formula. After that I am substituting the values. Curl of a bar plus b bar is equal to matrix I j k dou by dou x dou by dou y dou by dou z ax plus bx ay plus by az plus bz. We know that the det for I value, det for j value, det for k value, I am writing all these formulas here. We know the det formula AC minus BD. I am applying the above matrices. So after that I am separating the I values, j values and k values with respect to A and B vectors. So I am getting these equations. Curl of a bar plus b bar is equal to I dou az by dou y minus dou ay by dou z plus I of dou bz by dou y minus dou by dou z plus j of dou ax by dou z minus dou az by dou x plus j of dou bx by dou z minus dou bz by dou x plus k of dou ay by dou x minus dou ax by dou y plus k of dou by dou x minus dou bx by dou y. After that we are writing like this. So I values and j values and k values simply we can write like this. Curl of a bar plus b bar is equal to curl a bar plus curl b bar. Note, a bar is a vector said to be irrational if curl a bar is equal to 0. Standard 10. Curl of pi a bar is equal to pi curl a bar plus grad pi cross a bar. We know the formula curl s is equal to del cross s. So after that we are applying the formula. Curl pi a bar is equal to matrix I j k dou by dou x dou by dou y dou by dou z pi ax pi ay pi az. Here a bar is equal to axi plus ayj plus azk. I am substituting the value. After that we are taking the det value. After that I am rearranging the I values and j values, k values. So I am getting this equation. Curl of pi a bar is equal to pi of matrix I j k dou by dou x dou by dou y dou by dou z ax ay az plus I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z into axi plus ayj plus azk. So it seems to be like curl of pi a bar is equal to pi curl a bar plus grad pi cross a bar. Standard 11. Div of a cross b is equal to b dot curl a minus a dot curl b. Again we know the formula div s is equal to del dot s. So we are writing that formula here. So div a cross b is equal to, I am writing del operators first, I dou by dou x plus j dou by dou y plus k dou by dou z. Next one is the a cross b. We know the cross product of a cross b. So after getting the matrix we know the det formula. So applying the det formula I am writing this equation. I ay bz minus az by plus j az bx minus ax bz plus k ax by minus ay bx. So after that I am multiplying these two dot product with these two del dot a cross b. I am getting this equation dou by dou x of ay bz minus az by plus dou by dou y of az bx minus ax bz plus dou by dou y dou z of ax by minus ay bx. Next we are applying the uv formula, that is equal to ay dou bz by dou x plus bz dou ay by dou x minus az dou by by dou x plus by dou az by dou x. So we can write uv formula with respect to remaining terms. By using the above equation, we are separating the common terms. After that, we are writing the final equation. So div a bar cross b bar is equal to bx of dou az by dou y minus dou ay by dou z plus by of dou ax by dou z minus dou az by dou x plus bz of dou ay by dou x minus dou ax by dou y minus ax of dou bz by dou y minus dou by dou z plus ay of dou bx by dou z minus dou bz by dou x plus az of dou by dou x minus dou bx by dou y. So we know that bxi plus byj plus bzk represents b bar. So the remaining terms represents the depth of the matrices. So that represents curl a bar. Next one minus next axi plus ayj plus azk represents a bar. So that means a bar. Next one represents the depth of b bar, that represents curl b bar. So the above equation can be written like this: div a bar cross b bar is equal to b curl a bar minus a bar curl b bar. Line integral of a vector field. The integration of a vector along a line or a curve is called its line integral of a vector. It is represented as integration of a bar dot dr bar. Next one is the surface integral of a vector field. The integration of a vector a bar about the surface S bounded by a closed curve C. It is known as surface integral. It can be written like this: double integral S a bar dot ds bar. Next one, volume integral. If a bar is a vector corresponding to a volume V enclosed by a closed surface S, this can be written as triple integral V a bar dot dv bar. Next one, if pi is a scalar corresponding to a volume V enclosed by the surface S, then it can be written as triple integral V pi dot dv. It is called as the volume integral of a scalar over the volume V enclosed by the surface S. Stroke theorem. So this can be explained by the line integral, volume integral and surface integrals of the material. By using these three integrations, we are able to prove the stroke theorem. So stroke theorem statement: the line integral of a vector a bar along a closed curve C is equal to the surface integral of curl of vector a bar over the surface S bounded by that closed curve C. That is, closed integral 3 a dot dl is equal to double integral S curl a ds, that is equal to double integral S del cross a dot ds. This statement represents, suppose if you are taking any closed material, that material having the surface. So first of all, we are able to measure the line integral of one point. So then we are adding the number of line integrals, it will gives the surface integral of the closed curve. Next one, proof. Consider a surface S enclosed in a vector A. The boundary of the surface S in a closed curve PQR. Then the line integral of A around the curve PQR traced in clockwise direction is closed integral A dot dl. We know that the curl of a vector field at any point is maximum line integral of vector per unit area along the boundary of very small area at that point. So the line integral of A around the boundary of the area ds is given by curl A dot ds. This applies to all surface elements. Hence, the sum of the line integrals of A around the boundary of all area elements is given by double integral S curl A bar dot ds. The above equation represents the surface integral of A bar. Next one, the line integrals along the common sides of the continuous elements mutually cancelled because they are transversed in opposite directions. Now, the sides of the elements which lie in periphery of the surface, that is in the closed curve, contribute the line integral. The sum of the line integrals on the boundary line of the curve is given by closed integral A dot dl is equal to double integral S curl A dot ds, that is equal to double integral S del cross A into ds. So this shows that the stroke theorem. Next one is the Gauss divergence theorem. In this we are taking a surface integral that is equal to the volume integral of the divergence of a vector. The statement of the Gauss theorem is the surface integral of a vector A bar over the surface S is equal to the volume integral of a divergence of a vector A bar over the volume which is bounded by the surface S. So that is double integral S A dot ds is equal to triple integral V div A dv, that is equal to triple integral V del dot dv. Proof. Consider a closed surface S of any arbitrary vector field A. The whole volume may be assumed to be divided into a very large number of cubical elements adjoining to each other. By using the figures, we know that div A represents the amount of flux diverging per unit volume. Hence, the flux diverging from the element of volume dV can be written as div A dV. So, the total flux coming out from the entire surface is given by triple integral V div A dV. Now, we consider a small element of area ds on the surface S. Let n cap be the unit vector drawn from the normal to the area ds. Next one, the normal n cap makes an angle theta. So this can be written like this: a cos theta is equal to a dot n cap. The flux A bar through the surface element ds is given by a dot n cap into ds is equal to a dot ds. So the total flux through the entire surface is given by double integral s a dot ds, that is equation 2. By using about two equations like volume integral and surface integral, these two be equal. That means this must be equal to the total flux diverging from the whole volume V enclosed by the surface, that is equal to double integral s a dot ds is equal to triple integral V div a dv. This represents the Gauss theorem of divergence. This is also can be written as double integral s a dot n cap ds is equal to triple integral V del dot a dv. Thank you.